Now the midpoint formula, if we are trying to find the midpoint between something like 2, 7, and 6, 3, we know that the midpoint is the thing that is directly in the middle between those 2 points. And what that means is that you've taken your x values and found the middle, and you've taken your y values and you've found the middle. This idea of in the middle, right? Kind of like your mid-interval value that we just talked about in our last unit. The mid value is the average of those values. So if we're trying to go in the middle of our x values and in the middle of our y values, we're really just finding the average of our x values and the average of our y values. Finding the midpoint is just finding the average of your point. So if I were to find the average of the x values, 2, 6, I would add them together and then divide by how many I added, which is 2. Same with my y values, 7 plus 3 divided by 2. Quick reminder in case any of you thought of this, remember if there's a plus in between, things cannot cancel out. So you do have to add 2 plus 6 is 8 divided by 2, which is 4. 7 plus 3 is 10 divided by 2 is 5. So that's the general idea of finding the midpoint. If we were to turn it into a formula, we then just say, I'm getting a little crowded, sorry. We take those x values and then add them together and then divide by 2. Same with the y values. Add them together and then divide by 2. It will also be the same. This is for 2-dimensional. For 3-dimensional, it will be those x values averaged out, the y values averaged out, and hopefully you guessed it, just the z values averaged out. Okay, so let's practice it. Find the midpoint that connects these 2 points. So I'm just finding the average. The midpoint would be 2 plus 6 divided by 2, 4 plus 12 divided by 2, which gives us 4, 8. And that is our point. Really straightforward, pretty easy. I would say this is probably one of the easiest things that we do in this class. The point C is the midpoint of the segment connecting this point and this point. So if we have a point that's like -1, -1, and we've got a point that's C that's 4, 3, and it's the midpoint, we can even visualize that this would be the point MN, that we're continuing it out, that this distance is equal to this distance. If you ever want to, drawing a picture is a great way to visualize what's going on. So we know that we're trying to continue that distance. You can probably just problem solve this by saying, well, hey, I know that the x distance is just going to be doubled over here, right? The x distance here, the distance between -1 and 4, is 5. So I can tell you right now, I know that 4 plus 5 is then going to be 9. So m is 9. -1 to 3 in the y values, that's a distance of 4. So I would just add another distance of 4 up to here, which means that 3 plus 4 is 7. I can tell you that n will be 7 because I'm just continuing that distance up here. But you can also do this in a formula way. How do you solve for the midpoint? Well, you average out the 2 values. If it's the midpoint between these two, you do -1 plus m divided by 2, -1, plus n divided by 2, and we know that that will give us the midpoint, 4, 3. Matching up the things that we know go together, we know that this should give us 4, and we know that this should give us 3. So just make some mini equations. -1 plus m divided by 2 equals 4. -1 plus n divided by 2 equals 3. You can numerical solve it, or you can do 2 times 4 is 8. And then I would have to add 1 to both sides because it's a -1. Multiplying by 2, I get -1 plus n equals 6. Adding 1 to both sides, I get 7. It does say find the coordinates of the point. So the coordinates of the point is 9, 7. Exactly what I hypothesized before by looking at the pattern of what I know about midpoints, but you can also use a formula to just keep track of this. Okay, we have 2 more IB type problems, and that will be it for today. A tracking station lies at the origin of the coordinate system With the x-axis due east, y-axis due north, and z-axis vertically upwards. Two aircrafts have the coordinates that and that relative to the tracking station. So if I were to draw a picture of what's going on here, I've got my x-axis here, my y-axis here, and my z-axis here. We have, at a point right here, the tracking station. It says, hey, at the origin is the tracking station. Origin is 0, 0, 0, or in a two-dimensional way, 0, 0. So this is our tracking station, and then we have these points, x, y, z. So I've went out 20 over 25, and then up 11. It looks kind of wonky, but it's this idea of you've come out a little bit and then over, and then now you're up a little bit more. And so the perspective gets a little wonky, but that's the idea. And we can say that that's the coordinate 20, 25, 11. And then 26 would go out just a little bit further, 31 would go just a little bit further, and then the next one would go up just a little bit more, and that would be 26, 31, 12. So it says, first of all, we just want to find the distance between these two aircrafts. So we've got these aircrafts out in space, and we want to find the distance between the two of them. Well, I can just use my distance formula. Go ahead and try that on your own. So hopefully when you put it together, I would definitely recommend writing out the equation with the numbers first. Sometimes the subtractions can trip you up. Sometimes if there's a negative, it can trip you up. And so make sure that you're writing out those numbers just to help future you out to keep track of things. So I'm going to subtract the x values. It doesn't matter which way you subtract them, because since we're squaring it, it all kind of, as we say, comes out in the wash, which means that it all just in the end ends up exactly the way it would have if it was the other way around. So it doesn't matter which way you subtract them. So when you go ahead and subtract them, plug it into your calculator, you should get 8.54 kilometers. Double check that you're putting parentheses. If you decided to put all of this just straight up into your input line, make sure you're putting parentheses around 20 minus 26. Maybe you didn't do that and got a wonky number. Make sure that you're subtracting inside the parentheses and adding outside the parentheses. Make sure that your square root encompasses all of it. Those might be some tricky things if you didn't get the problem correct. Okay, the radar at the tracking station has a range of 40 kilometers. So the distance between these guys is almost, it's about like 8.5 kilometers. So it says from the tracking station, we have a distance that we can read at a distance of 40 kilometers. If they're within the 40 kilometer radius of this tracking station, then it will be picked up on their radar. Determine whether it'll be able to detect both aircrafts. So that means that we need to find out the distance from the tracking station to this guy and the distance from the tracking station to this guy right here. And the hope is that if they are under 40 kilometers, then we can track them. If they're over 40 kilometers, then we cannot track them. I'm going to label this guy as A, and I'm going to label this guy as B. I'm going to find out the distance from the tracking station to A and the distance from the tracking station to B. The tracking station has the coordinates 0, 0, 0, which means when I'm finding the distance and I'm writing out my formula, it's 0 minus 20 squared plus 0 minus 25 squared plus 0 minus 11 squared, which is really just 20 squared plus 25 squared plus 11 squared. It doesn't matter if it was a negative because squaring it would just make it positive anyway, so it doesn't matter. So really just finding the distances for these guys is just taking the coordinates and then squaring them, adding them together and taking the square root. Go ahead and find the distances for the tracking station to A as well as the tracking station to B. For A, you should have gotten 33.9 kilometers. And for the distance from the tracking station to B, you should have gotten 42.2 kilometers. This all means that the tracking station can pick up aircraft A, but it cannot pick up aircraft B. So tracking station, you should be writing this down as well because the official question needs you to answer what the question was. Tracking station cannot pick up aircraft B, which I've labeled with the coordinates 26, 31, 12. Last example. The vertices of a sail are plotted on a pair of coordinate axes, and the following coordinates, show the triangular sail, triangle ABC, is shaped as a right. Show that the triangular sail ABC is shaped as a right-angled triangle. So if I wanted to visually represent it, it doesn't have to be perfect, but I can go in here and say, okay, -4/6 means I'm going over, I don't know, that, let's say that's -4. I know that 6 would be a little bit longer than that distance in an up way. It doesn't have to be exact, but I do want to visually think about what's going on here. B is then 6, which is a little bit further than this distance here, exactly the same distance as up here, but just eyeball it. And then 2, so that's B, which is 6, 2. And then 8, which C, which is -8, -4, right here. Okay, so I have visually represented it, and I want to prove that this is a right-angled triangle. The only way that we can prove that something is a right-angled triangle is to be able to use the Pythagorean theorem. And if we use the Pythagorean theorem and the Pythagorean theorem holds true in this situation, then we can say, hey, since it satisfies the Pythagorean theorem, that it means that it must be a right-angled triangle. In order to know that it satisfies the Pythagorean theorem, I need to find these distances. I need to find this distance, and this distance. Remember that your hypotenuse will always be the longest side. So you can always determine which one's going to be your hypotenuse by the time you get to the end. First things first, we need to find the distances. I need to find AB, I need to find BC, and I need to find AC. Go ahead and leave them in square roots because it's going to be easier to plug it into the Pythagorean theorem. You'll see later, but go ahead and find all of those distances for me. AB is the square root of -4 minus 6 squared plus 6 minus 2 squared. These negatives, I'm sure, got at least some of you confused, and so making sure that you write this out at the beginning is really important because -4 minus 6 is -10. -10 squared is 100. 6 minus 2 is 4, squared is 16, so this ends up being the square root of 116. BC, in order to solve for that, 6 is going to be plus 8 because I'm subtracting a negative, 2 minus a negative, so 2 plus 4 squared. 6 plus 8 is 14. 14 squared is 196. 196 plus, this is going to be 36, is 232. And then the last one's going to be -4 plus 8 squared plus 6 plus 4 squared, because that -8, -4, subtraction of a negative ends up becoming a positive. So the -8 plus 4, that's 16. 6 plus 4, that's 100. So that ends up being the square root of 116, which is cool that those guys are the same. But that's not really what we care about here. We care about, do they satisfy the Pythagorean theorem? The Pythagorean theorem is a squared plus b squared equals c squared. C has to be the longest side. The longest side is the square root of 232. So if I do the square root of 232 squared equals, and then it doesn't matter which one, it ends up being 116, which is 232, which equals 232, which means that it satisfies the Pythagorean theorem. All it says is show. It doesn't say, is it a right triangle? It doesn't say, explain to me why it is a right triangle. It just says, show. You have shown that it is a right triangle. E basta. You're done. Great job today. I'm sorry these notes were a little bit long. We'll go ahead and continue practicing this in class.